Hello everyone and welcome to my channel Chemistry by Miss Nidhi. In today's class, we will be talking about writing chemical formulas. This topic is from grade 9, chapter 3, Atoms and Molecules. And in this video, we will be covering some basic concepts, some most commonly made errors, and shortcut to writing chemical formulas. So let's get started. First thing first. In chemistry, you would very often see a letter with sometimes a number written near the head of the letter. Other times you would see it written at the foot of the letter. These numbers mean something. So when something is written near the head of a letter or superscript, it basically means charges. And it's always accompanied by a plus or a minus sign. So if you see this thing, it means that sodium atom here is carrying one positive charge. If you see this, it means magnesium atom here carries 2 plus charge. Then you might see this. This means chlorine atom here carries a -1 charge. And this means that oxygen here is carrying a -2 charge. Sometimes you would also see a group of atoms carrying some charges. Okay, but that would always also be in superscript. Now, what does subscript mean? Subscript usually denotes the atomicity of a molecule. So if you have a subscript next to an element, basically it's a molecule, right? So let's see with an example, what does this atomicity mean? So if you have O2 written like this, it means that in one molecule of oxygen, you have 2 oxygen atoms. Similarly, here in carbon dioxide, it means that one molecule of carbon dioxide has 1 carbon atom and 2 oxygen atoms. Likewise, here we have ammonia, which has 1 nitrogen atom and 3 hydrogen atoms. Let's check the overall atomicity of the molecules. O2, since it has 2 oxygen atoms, you can say that O2 is a diatomic molecule. Similarly, you can call carbon dioxide a triatomic molecule, since it has a total of 3 atoms, 1 carbon and 2 oxygens. Next, ammonia, you can call it tetraatomic molecule. Okay, and if it has more than that, we usually call it polyatomic. Now let's test our knowledge. This molecule right here is called as calcium phosphate. And what it has is 3 calciums. That is pretty obvious. But what is this? Sometimes you would see that in some formulas, there is some bracket. And there is usually a number written right outside the bracket on to the right. When that happens, you should know that this number gets multiplied with whatever is inside the bracket. So this 2 gets multiplied with phosphorus and 4 atoms of oxygen. So in one molecule of calcium phosphate, we have 3 calciums, 2 phosphorus, and a total of 8 oxygen atoms. So the total atomicity of calcium phosphate is 13. Okay? If you understand this, writing chemical formulas should be very, very easy for you. Now, but before we jump to that, we need to understand what cations are. Cations are positively charged ions. They can be monoatomic or polyatomic. Monoatomic ions, as the name suggests, have just 1 atom, and monoatomic cation means that 1 atom is carrying a positive charge. So sodium plus is an example. Magnesium 2 plus is another example, calcium 2 plus, aluminium 3 plus, hydrogen plus. These are all monoatomic cations because in here 1 atom carries a charge, a positive charge, or more than 1 positive charge like 2 positive or 3 positive. Polyatomic cations are the ones where a group of atom is carrying a positive charge. So ammonium here has 1 nitrogen and 4 hydrogens carrying a positive charge. This is called as ammonium ion. We also have hydronium, but we don't have many polyatomic cations, right? Now, when we talk about suffix in cations, many times there is usually no suffix. For example, this one is iron 2 ion, this one is iron 3 plus ion, then we have silver plus, copper 2 plus, hydrogen. All these ions do not carry any suffix, right? Just the name and the charge. But other times we have em as a suffix for cation, usually whenever it is a polyatomic cation. Example, ammonium, hydronium. But you would often see that this is sodium, magnesium, aluminium. They also have em suffix, but that's kind of built in the name of the element, right? Okay, so that was cations for you. Moving on to anions. Anions are negatively charged ions. They also can be of two types, monatomic, polyatomic. Monatomic, single atom carrying a charge, like chloride, oxide, nitride. Polyatomic is when a group of atom is carrying a negative charge. Polyatomic anion, that is. So we have many polyatomic anions. Hydroxide is the simplest one, but then we have carbonate, hydrogen carbonate, sulfate, sulfite, nitrate, nitrite, phosphate. I think I covered them all. Okay. So now talking about suffixes, so anions are always accompanied by a suffix. They always have a suffix. The suffix are either "ide" or "ate" or "ite." "Ide" suffix you would see that is mostly associated with monoatomic anions such as fluoride, chloride, bromide, iodide, oxide, sulfide, nitride, but mostly, not always, because we also have hydroxide, which is a polyatomic ion but still carrying a suffix which is "ide." Then we have "ate" and "ite." Now sometimes you would see very similar looking ions, but the names would be different. For example, this is sulfate and this is sulfite. This is nitrate, this is nitrite. Okay, now here if you see the ions carrying "ate" suffix, they have one more oxygen than the ions carrying "ite" suffix. So sulfate has 4 oxygen and sulfite has 3 oxygen, one less oxygen. Nitrate has 3 oxygens, but nitrite has 1 less, that is 2 oxygens. So if you know the formula for sulfate and nitrate, sulfite and nitrite should be easy because that's the same, just 1 less oxygen. Even the charges remain the same, right? So I hope that would make learning the ions a little bit easier. These are the most commonly used ions. There are some monatomic ions, cation and anions mixed, and then there are some polyatomic anions and cations. Now, you would notice that we have 2 copper cations and 2 iron cations. Now, good news is that whenever you get copper and iron compounds, you would be told which ion to use. Okay, if it doesn't make much sense right now, you would see that in example. So let's start with the examples. The first one is sodium chloride. So when we have a compound called sodium chloride, it has formed when the ions sodium and chloride combined to form compound in such a way that their charges got balanced, and the compound thus formed is electrically neutral. Now what does that mean? Sodium chloride, you have sodium ion and chloride ion, and they will come together to form a compound sodium chloride in such a way that their charges get balanced. So when you have sodium chloride as a compound, the compound will not carry any charge. Okay, now since sodium and chloride have equal and opposite charge, one sodium is enough to balance the charge on one chloride. So they will combine in 1:1 ratio. and form sodium chloride. Now, please do not make the mistake of writing it like this. Sometimes students just bring the ions closer and let the charges be. Please don't do that, because when they have combined, the purpose of combining is to electrically neutralize each other. And when they have done so, why would you write the charge? Right? Okay. Next example is magnesium chloride. Magnesium chloride, we will have magnesium and chloride. Now always notice that whenever a compound is given, the first part of the compound is always the cation and the second part would always be anion. Okay, so now magnesium has 2 plus charge, chloride has only -1 charge. So their charges are opposite but not equal. So how would they electrically neutralize each other? One chloride ion would not be enough to balance the charge on one magnesium ion. So what we can do is we can take 2 of them, but we cannot under any circumstances change the charge on any ion. We cannot just make chloride Cl-2. We can't do that. But what we can do is take 2 of them if need be. Okay. So here magnesium 2 plus charge is electrically neutralized by 2 chloride ions because together it becomes a 2 negative charge, right? So magnesium chloride is formed by 1 magnesium and 2 chlorides. So this is what you get, MgCl2. Again, notice that in name and in formula, cation is written first and then it's followed by the anion. Now, this is another way of showing how this works. Now imagine that these ions are Legos. So this blue Lego is magnesium. Okay, and the 2 plus charge is reflected in the 2 holes here, right? And chloride ions are these 2 Legos, each one having just 1 bump. So if you want to make one compound from magnesium chloride, you cannot change the anion here and make it double. But what you can do is take 2 of them, right? And then you get the charges electrically neutralized. Okay, all right. Moving on to the next example, calcium sulfide. Calcium carrying 2 plus charge, sulfide carrying 2 minus charge. Again, charges are equal and opposite, so they can combine in 1:1 ratio. So this is calcium sulfide for you. Now, coming on to iron 3 oxide. Like I said, iron has sometimes 2 plus charge, other times it carries 3 plus charge. So whatever the charge it carries, it would be reflected in the name of the compound given to you. So iron 3 oxide has iron carrying 3 plus charge. An oxide usually is only -2, right? Now, how would you balance the charges? Now this time iron has 3 plus, your cation has 3 plus and your anion has 2 minus, right? So they are not equal and opposite. So what you can do is multiply them with each other. For example, multiply 3 with 2 and 2 with 3, right? So that would give you this. So basically you have to take 2 iron 3 plus ions and 3 oxide ions, so that here the total charge becomes +6 and here the total charge becomes -6. Now the formula of the compound of iron 3 oxide would be Fe2O3, right? Okay, let's try aluminium carbonate. Aluminium has 3 plus charge. Carbonate is a polyatomic anion carrying 2 negative charge. So you know what to do. You have to take 2 aluminiums and 3 carbonates, right? So that here it is -6 in total, here it is +6 in total. So the formula becomes Al2CO3, 3. You have to take 3 of them, so you would write 3. But can we write it like this? Check the atomicity of this. It means you have 2 aluminium, 1 carbon and 33 oxygens. But that's not what we mean. From here you can see that the compound will have 2 aluminiums, 3 carbons and 3 plus 3 plus 3, 9 oxygen atoms, no more, right? So you can show that if you put a bracket outside carbonate, right? Now this would mean exactly this, that there are 2 aluminiums, 3 carbons and 9 oxygens, right? So this is the importance of putting bracket. Now you have to put bracket outside a polyatomic ion only when you have more than one of them. Okay, if you have only one polyatomic anion or cation, you do not need to put any bracket, right? So let's do this example where the polyatomic ion is the polyatomic cation, ammonium sulfide. Ammonium is NH4 plus, sulfide is 2 minus. You would have to take 2 of ammonium. That will give you 2 ammoniums, and since it's a polyatomic cation which is present in more than one number, so we'll have to put a bracket, and sulfide is written as it is, right? So this is the formula for ammonium sulfide. Now let's discuss the shortcut. I actually prefer that you do it logically, just the way I explained just now, because that way, in my experience, I've seen that students make fewer mistakes or no mistakes at all. Students are more likely to make more mistakes if they use this crisscross method. But if you're sure that you can get it right without any mistakes, go ahead and use it. Now, first example is calcium nitride. So in this case, in this method, what you do is you write the ions, but you would not write the ions on top of, in superscript. You would write the charges below the name, below the symbols of the elements, and then you would just crisscross. So Ca gets 3, nitrogen gets 2. Similarly, magnesium oxide, Mg 2 plus and oxygen 2 minus. So how you have to write it? You would write their charges below them without writing plus or minus sign, and just after that criss and cross. So magnesium gets 2, oxygen gets 2. But here, this is important, you have to take the simplest ratio, okay? And 2:2 is not the simplest ratio. The simplest ratio would be 1:1. So Mg2O2 becomes MgO. The last example I'm going to take is ammonium sulfate. So here also, you would write the ions and the charges below them and then just crisscross. This example has both polyatomic ions, but only ammonium is getting a 2 or more than one number. So only ammonium will get a bracket and 2 outside it, and sulfate, since it's getting just one number, you don't need to write it. You don't need to put a bracket or write the number. Okay, so this is the formula for ammonium sulfate. Now, thank you for watching, and if this video helped clear some of your doubts or making the topic easy, please subscribe, share and like. Thank you so much.